Today we're going to be creating our review video for section 9.2. That's chapter 9, section 2. And the learning target that we're going to be working with today is to complete functions and function tables. Well, we've got a few terms that we have to get here. The first one is what a function is, a relation in which each element of the input is paired with exactly one element of the output according to a specific rule. This will make a lot more sense when you see an example. The domain is the range of input values. Input is in the domain. Which values do you put in, which values do you start with and plug into the equation. The range is the output. The set of output values in a function is the range. And the function table is a table organizing the input, the rule, and the output of a function. Okay, well, let's just jump in and do a few here. We can see that we have f of 4 if, so that's the input, all right? And here's the rule, if f of x is equal to x minus 8. So let's plug in here. We'll say f of 4 is equal to, instead of writing x, I write the value 4 because I'm inputting that minus 8. So f of 4 then is equal to 4 minus 8, or negative 4. Negative 4 is the output, or the range at this point. How about if f of 2, if f of x is equal to x minus 7, so f of 2 is equal to 2 minus 7. I plug 2 in for the x, 2 in for 7. 2 minus 7 is a negative 5, so f of 2 is equal to negative 5. F of negative 6 if f of x is equal to 3x plus 4. So f of negative 6 is equal to 3 times the negative 6. I input that in, put in negative 6 plus 4. 3 times the negative 6 is a negative 18, plus 4 would be equal to a negative 14. So my output would be negative 14. F of negative 2 is going to be my input. The rule is going to be, f of negative 2 is going to be equal to 2x plus 6. So it's 2 times the negative 2 plus 6. 2 times the negative 2 is negative 4. Negative 4 plus 6 would become 2. So the output f of negative 2 would be equal to 2. Okay. Well, here's a function table. It does just exactly what we've been doing on the other steps, but it's going to organize the input for, or it's going to organize the information for multiple inputs into the f of x equation. So the f of x equation is 4x minus 1. There's the rule, 4x minus 1. And I'm going to input each of these values. So I'm going to say 4 times the negative 3 minus 1. 4 times negative 3 is negative 12, minus 1 would be a negative 13. My output would be negative 13. All right, I'm going to input now negative 2. So 4 times a negative 2 minus 1. 4 times a negative 2 is minus 8. Minus 1 would be minus 9. Negative 1 is input, so 4 times a negative 1 minus 1. 4 times negative 1 is negative 4. Minus 1 would be negative 5. So again, these are my input, or my domains are in this column. My range, or my output, is in this column. 0, 4 times 0 minus 1. 4 times 0 is 0. Minus 1 would be negative 1. And 1, 4 times 1 minus 1. 4 times 1 is 4. Minus 1 would be 3. Okay, now that's my my inputs is called the domain. So my domain is equal to negative 3, negative 2, negative 1, 0, and 1. That's my domain. My range, which is my outputs, right? My range is equal to negative 13, negative 9, negative 5, negative 1, and 3. Those are my outputs, or my range. So we've got domain and range there. Okay? Complete the function table. F of x is equal to x minus 2. I'm sorry, 3x minus 2. So you can see here's my rule. Here's my inputs, and I'm going to find my outputs. So I'm going to plug each of those into the function. I'm going to say 3x, 3 times negative 3 minus 2. 3 times negative 3 is, of course, negative 9. Minus 2 would be a negative 11 is my output. Here is, I'm going to plug in negative 2, so I've got 3 times a negative 2 minus 2. 3 times a negative 2 is negative 6, minus 2 would be negative 8 is my output. Remember, the inputs are my domains, the outputs are my range. So we're calculating all those. Plugging in negative 1, 3 times a negative 1 minus 2. 3 times negative 1 is negative 3, minus 2 would be negative 5. And plugging in 0, 3 times 0 minus 2. 3 times 0 is 0, minus 2 is negative 2. Last one, 3 times 1 minus 2. 3 times 1 is 3, minus 2 is 1. So my domain in each of these is my input values. It's negative 3, negative 2, negative 1, 0, and 1. And my range is equal to negative 11, negative 8, negative 5, negative 2, and 1. So there's the domain and ranges for that function. We're going to write our own function here. We're going to write our own rules to govern this situation. The price for parking at a city lot is $3 plus $2 per hour. Write a function using two variables to represent the price of parking for H hours. Well, I'm going to say that the price of parking is equal to $3 plus 2 times the number of hours. 2 times the number of hours. Okay, so that's my function. My input here for this is going to be 2 hours. So I'm going to say parking, the cost for parking is equal to $3 plus $2 per hour times 2 hours. 2 times 2 is 4 plus $3. The cost to park then is equal to $7 to park for the 2-hour time period. One more. The price for a taxi ride is $5 plus $20 per hour. Write a function using two variables to represent the price of riding a taxi for H hours. Well, I'm going to say that P is equal to the price, and that's going to be equal to $5 plus $20 times the number of hours that I ride. All right, that's my function here, so I'm going to say then the price is equal to $5 plus 20 times 3 hours for a 3-hour taxi ride. Of course, 20 times 3 is $60. $60 plus the 5. The price to ride in the taxi for 3 hours is $65. Thank you.